Okay, so there were several that did not do very well on that last test, and that last test is sort of a tell for the rest of the year because we use what's on the last test all the way through the rest of the year. So as a chemistry department, we came together and we decided we were going to offer a retake. However, you have to attend a reteach tutorial. So the reteach tutorial will be Friday or Monday. So you don't have to come to both, but you can. But you got to come to either Friday or Monday to be able to retake the test. If you haven't taken the test, the same time period is going to be available to you to take the test for the first time. But if you want a second chance for the test, then the test dates are Monday after school or Tuesday at 7:15. Okay? So if you haven't taken the test and you want a chance for a retake, then you need to come to one of the tutorials and do it. And then if you do poorly on Monday night, I would take the test on Monday night, then you have a chance to retake it on Tuesday. Okay? But if you haven't come to the reteach and you haven't taken the test, then when you take the test, it's a one and done. Okay? So if you need to retake it or want to retake it, Friday tutorial or Monday tutorial, there will be a worksheet that you have to finish as your ticket into the retest. Okay? So if you finish that, that will be your ticket into it. If you have taken it before, if you haven't taken it before, you don't have to have the reteach to get in. The first time, if you want to try it for the second time, then you do. Okay? Questions on that? So we don't do that very often. In fact, we actually cleared through the admin that one of us would be in charge of watching kids that want to do the test on Tuesday morning while the other one went to faculty meeting. So this is a not very often thing that we do. But this is such an important test that you know how to do because we're using it the rest of the year. Okay, so naming and writing chemical formulas, that's sort of what chemistry is all about. Okay, so if you did bad on it, we really want you to learn how to do it. Yes?
So, with the worksheet, would you give that to us, like, at one of the reteaches?
Yes. Okay. Yep, you'll get it at one of the reteach. I don't know if that's one of yours or not. Okay, so here we go. We are going into chemical reactions. You should have a packet that we are going to go through today. A lot of the kids last period easily finished and uploaded, so that'll be good. If you've had this in 8th grade, just bear with and you'll be good. All right, so yeah, a lot of kids said they had in 8th grade. This is what we're going to do today, so just a rundown real quick. You should have finished quiz 5.1. I'll be coming around after we finish the lecture and seeing what your score is. If you haven't finished, you'll have a chance to finish then. Today during lecture, we're going to talk about conservation of mass, reactants, products, balancing equations. And then at the end of the day, you'll turn in daily work 5.1. Okay, so first thing I want to do is I want to just refresh your brain. So this is, you should already have that big paper that we did all the types of naming on. I'm just going to refresh your brain. Okay, so if I'm trying to write a formula for something, the first thing I want to do is say, okay, is the first element a metal? Remember that's the D, the S, the F, and the lower part of the P. Is it a metal? If the answer is yes, then is the metal one of the first two columns or is it a slide? Okay, if it is the first two columns, remember column 1 is +1, column 2 is +2. The slide is boron, aluminum, gallium +3, zinc +2, silver +1. Then that was type, whoops, I'm going the wrong way. Why is it doing that? Okay, that is type 1, where the charges are known. And we just make the charges add to 0. So we find out how many of each one we need to make it add to 0. And that's our formula. Okay? If the answer to that was no, then I need to look for the Roman numerals. Remember, the Roman numeral tells me the charge on the metal. That's the first element. A lot of you are getting confused and thinking that's how many of that element there is. No. Roman numeral tells me the charge. Then I still need to balance it. Okay? So don't get that confused. It has to add to 0. Now, if I go back here and the first element was not a metal, I said no. And then I ask the question, come on, is the first element hydrogen? If I say no, then we use the type 3 naming. That's the one I cautioned you about, that once you learn this, you think everything named that way. And that's what a lot of you did. But remember, this has to have the prefixes, the mono, di, tri. It tells me how many of that element there is. A lot of you are getting that mixed up. Like if it said nitrogen trichloride, a lot of you are giving me N3Cl. Well, it told me trichloride, not trinitrogen. So it should have been NCl3. Okay, so be careful. First element is not hydrogen, or is hydrogen, then we got an acid. Remember, hydro tells me it's just hydrogen and one other element. If it doesn't have hydro, then that's when we had hydrogen with a polyatomic. We're still balancing charges with acids, but we're not changing the negative part. We're changing how many hydrogens I have. So I just have to say how many hydrogens are going to balance that out to make 0. Remember, if it was ick, it came from 8, Thanksgiving dinner. If it was OUS, we're going to get in a fight. It came from fight, okay? So ITE, ITE. That still has to balance to 0. So type 4, type 2, type 1 have to balance to 0. Type 3, I don't worry about the charges. They tell me how many of each one, okay? So I want to make sure that that just sort of processes. We're going to be using this the rest of the year. That's why I made you that big chart so you could write that down in case you forgot, okay? All right, so that was our little quick review. We're going to go into reactions. Now, reactions are all about chemical change. When I convert something into something new, okay? But I can't, I'm just breaking bonds. So here I have a log, and a log is made up of cellulose. And if I burn that log, I'm not going to be able to get that log back, right, the way it was before. I'm going to end up with ash, which is mostly carbon and some carbon oxides and some other chemicals, because it's not just carbon and oxygen, they're in there. So I get new products. So I had reactants, but then I get new products. That's a chemical reaction. So how do I know a chemical reaction took place? So think about that burning. How do I know? Change in color, okay? Light, smell, heat, good. What else? Sound, good. Any others? Okay, I'm going to start uncovering what I had up here and see what, whoa, maybe I'm not. This is not being happy today. I think there's a gremlin in here. Okay, so change in color, change in temperature, change in smell, change in taste. That would be like cookie dough making a cookie. The cookie dough tastes different than the cookie because a chemical reaction is taking place. I don't suggest you taste in lab. That's a bad thing, okay? Formation of a precipitate. Did it make a solid? Okay, it appears cloudy, or did a solid come out? Production of bubbles. Production of heat, light, or sound.
Ms. Howell,
Yes?
I sent a Brent to check out.
Okay.
Thank you.
These will be up on Canvas, so you can keep going. Okay, so if one of these takes place, we usually have a chemical reaction. Now, you've got to be careful, because a lot of people say, oh, well, I had ice and now it's liquid, so it must be a chemical reaction. That's a physical reaction. Remember we did that chemical physical lab? Okay, we're looking for something that changed so that I can't put it back the way it was. Okay? All right. Did we get all these down? No? Okay, wait a minute. Yeah, that's probably a good idea. Write something. Wow, okay. So evidence of a chemical reaction. We're actually going to be doing a lab coming up that you'll be able to see different reactions that take place. Most of them just because they form a precipitate. But we can be looking for gas bubbles. Production of heat would be like your hot packs or cold packs. Light would be like the light sticks that you use. Sound, like an air horn. Okay, all right, going forward, maybe. Okay, so we have to be able to write a chemical equation. In order to write a chemical equation, we need to know where things are. So, reactants are always written on the left. That's what I start with. The arrow always points to my products on the right. And the coefficients tell me how much of each of them I need or how much I get. Okay, so this is a chemical equation. Just the basics. So if you can squeeze that in, great. If not, we'll keep going with other stuff here in a minute. So there's going to be some symbols and stuff that we need to go over, and that's, I think, in your next, maybe. Let's see. Okay, so you have this. With my reactants, from what we just said, if I say my reactants are red, I like to use the color pencils, so you can use color pencils too, because I hate rewriting things. Then all I have to say is in this equation right here, what is before the arrow are my reactants. Okay, that's pretty easy. Now if I pick a different color, I can say, oh, what are my products? Remember, I told you the arrow pointed to my products, so they are right here. If you want to rewrite them down underneath there, that's fine, but I like to write less than I have to, so you can do whatever you'd like. You need to be able to tell me if I told you what is LiOH in this equation, you would be able to tell me it's a what? LiOH. It's a reactant, okay? I could pick anything in there, and you should be able to tell me if it's a reactant or a product, okay? All right. There are some symbols that we use for chemistry equations. The first one is the arrow, the reaction arrow. It always points to the product. It always tells me that a reaction is taking place. The delta sign tells us, it's usually written above the reaction arrow, and it tells us there's a change in heat, whether it be given off or taken in, but there's a change in heat. The S in parentheses means a solid. The L in parentheses means a liquid. The G in parentheses means a gas. And the AQ in parentheses means aqueous solution. That means it's dissolved in water. Okay, so think of Spanish, agua, it means water. So aqueous is dissolved in water. So these are some symbols we use a lot. There's other symbols that we'll be introducing as we go along the way, but these are probably the most common that you need to be aware of. And I don't think there's a place for you in your notes for the delta for heat or the reaction arrow, so you probably need to add those in and sort of explain what aqueous means. So if H2O is in a reaction, could I put it as AQ? No, because water is not dissolved in water, right? So in a reaction, H2O has to be a gas, liquid, or a solid. Okay, most often it's a gas being given off or a liquid being formed. Okay, so going forward, see if I can get this. No, there we go. We need to use what's called the conservation of mass. Well, if you just read the name of that, you sort of know what's going to happen. To conserve mass, right? So in the reactant side, it's going to have a certain mass. In the product side, it has to have the same mass. Otherwise, I don't have a balanced reaction. The coefficients are used to balance the reaction so that I have the same number of carbons on one side as I do on the other side, same number of hydrogens on the other side. In other words, I can't create carbons from one side to another. I can't have more carbons on one side or the other of the reaction. I can't create or destroy matter. It has to go somewhere. Okay, so we have to have the same number of atoms on both sides of each element. So to sort of look at this more visually for the law of conservation of matter, we're going to hopefully go forward. Maybe, I tried. I don't know what is stuck with it today. Okay, so this is a visual. I'm going to stay over here so that I can get it to go. Of this equation. This isn't one that you have, so just look up here. There's one down below that we're going to do in just a minute, but just sort of watch. This is a general combustion reaction. This is methane gas, which is CH4, plus oxygen, giving CO2 and water. Well, if you look right now, there's one carbon. Well, first of all, let's identify our reactants. So our reactants are on this side, our products are on this side. If we look at carbon, which is the gray one, we have one on this side and we have one on this side. So that looks balanced. If I go to the next one, I have 4 hydrogen atoms on this side, but I only have 2 hydrogen atoms on this side. I have to have 4. I can't just have 2 disappear. So in order to get another 2 hydrogen atoms, that's the only compound that had it, I'm going to have to put up another water. So I can have 4 hydrogen atoms on this side. When I do that, I now have 2 waters, so I've got to put a 2 in front of the water, saying I have 2. Over here now, oxygen, I have 2, but on this side I've got 1, 2, 3, 4, right? So I need 2 more on this side. So I'm going to put another oxygen over here, which is a O2. When I do that, I now have 2 O2s, so I've got to change this right here to be 2 O2s. Okay, so now the atoms in my reactants match the atoms in my product. That is conservation of mass. Okay, so this is the one that you've got in yours. I want you to pick 2 colors. I don't care what colors they are. You're going to draw this out just like I did. Okay, so it says it has 4 Fe's. So we're going to make 4 circles and label them Fe. I don't care what colors you use. So 4 circles that represent Fe. Then we've got 3 O2s. Now O2 are 2 oxygens that are hooked together. So again, we're going to make 3 of these 2 oxygens that are hooked together. Then we've got a new compound over here, Fe2O3. So I've got to put 2 Fe's hooked to 3 oxygens, sort of like this. But I have 2 of them, so I'm going to make 2 sets. I'll give you a second to write that down. Okay, so now what we need to do is we need to make sure they're the same on both sides. So if I write Fe right here, how many are on the reactant side? 4. How many are on the product side? 4. How many oxygens are there on the reactant side? 6. Good. How many oxygens are there on the product side? So it's the same. So by the conservation of mass, we now have a balanced reaction. We don't have elements just flying away from what we need to do. Okay. Come on. That's not even going over here. Okay, so equations are said to be balanced when matter is conserved. We want to, when we balance an equation, always leave hydrogen and oxygen to the very last to balance. Because if we try and balance them first, it makes a big headache. So this is how I remember it. Hydrogen, oxygen. That's the last thing I want to do. The last part of the year is Christmas. Christmas has Santa, and Santa says, ho, ho, ho. So I remember those are the 2 things I want to leave last, and I do the H and then the O. Okay, pretty easy. So let's go ahead and try to balance some equations. Now, I personally like to have just a scratch piece of paper, and I take that scratch piece of paper and I put it right underneath the equation. You have got some room, but I write big. And so if you write big like I do, you might want a scratch piece of paper, just tear it out. I went to the copy center to try and get some, and they didn't have any scratch this time. So this is what I do with my paper. Yes?
Wait, are we doing it right now?
Yeah, we're doing it right now. So if you have or want an extra paper, you can grab it out. So we've got a little bit of room. I made mine a little bit bigger. So underneath the arrow, this is how I do it. And it makes it very simple, very quick. I put all of the elements that are in the equation. Now you don't have to look at both sides, just look at one. Remember, hydrogen, oxygen, leave to very last. So I put sodium, phosphorus, skip oxygen, potassium, and now all that's left is oxygen and hydrogen. So then I go HO. Okay? I do that under the arrow, so I know that I'm looking either side of that. Then I say, okay, I've got how many sodiums on my reactant side? 3, good. How many sodiums on my product side? 1. I have to stop there because it's not balanced, right? I need to balance it before I go on. So I say, okay, if I put a 3 right here, then that will make that a 3, right? Everybody okay with that? All right, so then we go on to the next one. Phosphorus. Phosphorus has how many in the reactant? How many in the product? Good, so we're good, right? Don't have to do anything with that one. Okay, potassium, how many in the reactants? 1, how many in the products? Ooh, that's not balanced, so what do I need to do? Put a 3 in front of the KOH, good. And that makes that a 3. Now, luckily O and H aren't something I've already balanced, so I keep going. All right, now I'm looking at the H. That 3 comes through, so I now have 3 hydrogens on my reactant side. How many do I have on my product side? 3, good. This 3 also came through. Let's look at the oxygens. This gets a little bit trickier because oxygen's now in 2 places on both sides, so you got to count both of them. We have 4 here with the Na3PO4. We have 3 with the KOH, gives me a total of 7. Let's look on the other side. We have 3 with the NaOH, plus we have 4 with the K3PO4, and that's 7. Everything's balanced, I'm done. Okay, try the next one on your own. Yes, ma'am.
I'm confused on where the second 3 came from.
Which
For, hydrogen?
hydrogen? This 3 comes through, and this 3 comes through.
Oh, okay, so,
So once you put a 3 or a number in front, it goes through all of them.
okay, okay, I get that.
Okay? Okay, we're going to check this one in just a minute, so see what you can do. I'm just going to write the letters up underneath. Yes. Yeah.
So I'm kind of confused.
So just go one side at a time. How many AS's on this side?
That's,
No, that's just 1, because that 3 just goes to the chlorine.
Okay, so 1, then 2.
So now you got to stop because they're not the same number. And you have to come back here and fix this one. So
So
it's,
put it as a 2.
put a 2 in front. That changes that to a 2. Okay, now the chlorines. No, careful. This 2 comes through. So 2 times 3 is
2 times 3 is 5,
6.
6.
Okay, on this side you have chlorine is over here, right? So you just have 1.
So now we're going to have to put 6 over here.
Yep, and then change that to a 6. Okay, then sulfur.
Right here.
How many?
So 1,
How many on this side?
3.
Okay, so you got to fix that. Okay, so change that to a 3. Now hydrogens. 3 times 2 is
6.
6. And over here,
6.
6. Done.
So what about right here?
Don't write anything. It's blank.
That's kind of easy.
Okay. All right, let's see if we can do it together. If you got stuck, we'll do it together. So start slow. Arsenic, AS. There's 1 on the reactant side. There's 2 on the product side. So we put a 2 over here to change that to 2. Chlorine. Now this is where it gets a little tricky for some kids. That 2 comes through and times is the 6. So 2 times 3 is 6, or 2 times 3 is 6. The 2 comes through and times is this 3 to 6. There we go. And over here we have 1. So we're going to have to put a 6 here to make that 6. Sulfur. We have 1 on the reactant side. We have 3 on the product side. So I'm going to put a 3 right here. This becomes a 3. Hydrogen. Yes. 2 times 3 is 6. Okay. On the hydrogen, we're going to do the same thing. 3 times 2 is 6. And 6 times 1 is 6. And we're done. Now, when you have problems like this on your multiple choice, and we ask you to balance it, it won't be written out like this. We'll just say the coefficients are 2, 3, 1, 6. That's what you would be looking for. We don't write ones. Okay, when we're writing the regular chemical equation, we don't write once. But when we are trying to figure out is it balanced or not for an A, B, or C, it's a lot easier to write it this way than to write the whole thing out again, especially in the program you've got with all the issues with the subscripts. Okay, takes too long. So that's how it'll be written. Okay, let's go to the next one and do the next kind together. Wrong way. Okay, this one's fairly simple, right? You could probably do it without writing the Na and Cl underneath, but we'll do it. So Na1, chlorine 1, chlorine 2. So I got to go back and fix it. When I go back and fix it by putting a 2 here, it doesn't just mess up my chlorine, it messes up my sodium. Right? So if I balance something before and it messes it up, I've got to go back. So now I have 2 sodiums on this side. I need 2 on this side, so I put a 2 and I'm done. You do the next one. If you need help, let me know.
So, why do you cross out the ones?
Because when I put the 2, when I put a 2 here, the 2 came to the sodium and the chlorine. So now I've got 2 sodiums. I need to get 2 on that side. So that's why I put the 2 there. Yep.
So now we're doing this one.
Yep. Yep. You're getting it though. You got it. That's right. Doing good. Stay with me. Okay, so this one shouldn't have taken very long, I hope. This is an H and an O, right? So we've got 2 hydrogens. We've got 2 hydrogens. We've got 1 oxygen. We've got 2 oxygens. So we've got to go back and we've got to put a 2 here. When I do that, it changes that oxygen to a 2, but it also changes that hydrogen to a 4. You see that? Okay, now that means I got to fix the hydrogen on the other side. Well, it's a 2 right now. To get 4, I'm going to put a 2 in front of that. 2 times 2 is 4. Done. Okay? All right, let's go on the next type. Okay, this type right here, let's see. So, example, N and H. On the reactant side, we have how many nitrogens? 2. On the product side, 1. So what do I need to do? Times it by 2, and that gets a 2 there. Okay, hydrogens on the left side. Reactant side, 2. On the product side, how many? 6. Be careful. Yeah, that 2 comes through, so it is 6. So I do need to fix that. What do I need to do to fix it? Put this one, put a 3. Good. We got 6. Your turn. And 8. Really losing it today. Okay, this one should have been also pretty fast, right? This one was easy to look at. You got 1 iron, 8 sulfurs, 1 sulfur. So put an 8 there, but that messes up this and the iron. So come back and put an 8 in front of there, and you're good to go. Okay? All right, let's go on to the next one. Oops, wrong way, sorry. Okay. I'm going to do the bottom one this time. The reason why I'm going to do the bottom one, because it has one with parentheses, and I want you to sort of see what the parentheses look like. So on this one, we're going to do Al, S, H, and O. Okay? So Al on the left has how many? 1. How many on the right? 2. So I'm going to come over here and I'm going to put a 2. Changing this to a 2. Sulfurs on the left, or the reactant side. Just 1, right? Sulfurs on the product side, that 3 comes through. Okay, so there's 3. So I need to fix this side by putting a 3 here. All right, now I'm going to look at the hydrogens. How many hydrogens on my reactant side? 6. Good. The 3 times is a 2, so I get 6. So over here, what do I need to times? Well, I've got 2 over here, right? So what do I need to times that 2 by to get to 6? 3. I've got 6. Okay, oxygen's on the reactant side. 12. Good. 3 times 4 gives me 12. What about on the product side? Good. 3 times 4 again is 12, and we're done. You go ahead and do the one above. Okay, should have been a fairly easy one. I'm not going to write it, but you should have a 2 here and a 2 here. Is that what you got? We okay? Thumbs up, I'm getting this. I'm doing well. Thumbs down, I'm not. Thumbs sideways, I'm still a little confused. Okay, all right, let's do another. Oops, wrong way. Okay, I am doing the bottom one in yours. I moved it to the top, but I'm doing the bottom one of yours because this one has to have a trick. There are some combustion reactions, and this is a combustion reaction, that don't balance real nicely, and this top one is one of them. So let's go slow. We have carbon, hydrogen, and oxygen, right? And these are big numbers, 15 and 30. Usually combustion reactions, like even candle wax, is C42. So it's got big numbers. Okay, so we've got 15 carbons on this side, right? I have 1 carbon on this side. So what do I need to times by? 15. Now, I always balance with pencil because you're going to be erasing and going back and going right back and forth. So make sure you use pencil, or you have a very, with pen, you're going to have a whiteout. Okay, so hydrogen on the reactant side, 30, right? How many on the product side? 2. What do I need to times the 2 by to get to 30? 15. Okay, now I've got 30. Okay, oxygen on the reactant side, how many? 2. On the product side, be careful because it's in 2 places. Good. So I go 15 times 2, which is 30, plus another 15 gives me 45. But on my reactant side, I can only have evens. So I can go back and try and rebalance it, but there's a math trick that you can use that's really simple. If I times this 2 by 45 halves, am I going to get 45? The 2's will cancel, right? So if I put just for a minute 45 halves, the reaction is balanced, right? Because they're the same on both sides, all the way down, right? But I can't leave a fraction in my equation. So how do I, in math, get rid of a fraction? Well, a decimal is still a fraction. Multiply by another fraction, or multiply, it's like a recipe. I need to double this recipe to get rid of that half, right? So I'm going to double it all the way through. So I'm going to make this a 2. I'm going to erase this and make it a 45. I'm going to erase this and make it a 30. I'm going to erase this and make it a 30. I have a balanced equation with really big numbers, but I didn't have to stress too far out with it. As long as I remember, I can times it by whatever divided by 2. Whatever number I need divided by 2. And then times the whole equation through by 2. Okay, you go ahead and do the bottom one. This one on the bottom does not need that trick.
Is there another way to do it without the...
It would be hit and miss. You just have to keep putting numbers in. So it's a lot easier to remember this little trick than trying to figure out, because how would you guess that there'd be a 45 in front of the oxygen? I mean, it's just nasty if you don't know the trick. How'd you do? Thumbs up, I got it, I got it, I got it. Thumbs down, I didn't. Thumbs sideways, I didn't get finished. Okay, so how are you feeling about this balancing? Pretty easy? Okay, we've got just a little bit of homework to do, but I want to have you stay with me just for a minute because they got really confused, whoops, on this next part, the first part of the practice. So just stay with me for this. Would you really quickly balance that? Just really quickly balance that. That's the easy part. So just balance on your practice, number 1. Go ahead and balance it. Yes. So you do pick out the ones that are not hydrogen or oxygen first. So nitrogen you put under here, magnesium you put under here, and then all that's left is hydrogen and oxygen, right? So then you put H and O at the very end. So you have 4 things.
Just confused with that.
Yep. Okay, we'll give everybody about another minute to finish up, and then I'm going to ask somebody to tell me what the numbers are in front of all those. Yes? Uh-huh. So right underneath the arrow, you're going to put a nitrogen and magnesium. So you're ignoring hydrogen and oxygen to very last. Magnesium. And then you would put the hydrogen and oxygen because that's all that's left. Okay, now balance side to side. So how many nitrogens do you have on this side? Nope, just 1. It only comes through if it's in parentheses. And this one does come through, so that you have how many? 2, yep. So now balance that over here by putting a what in front? A 2. Mm-hmm. It becomes a 2, yep. So now I'm going on to magnesium. I have 1 and 1, done. Don't have to do anything there, just 1, 1. Then I go to hydrogens. I got 2 plus 2 is 4. And over here you have 2. So what do you need to do? Put a 2 in there, right? 2 times 2 is 4. Okay, and then you go 2 times 3 is 6, plus another 2 gives me what?
8.
And then you've got 2 plus 3 times 2 is 6, so 2 plus 6 is 8, and you're done. Yes? Okay, so 2 times 3 is 6, plus another 2 is 8. So you have it balanced. Yeah. Okay, so I know there's some more hands up, but I'm going to do it up here with us real quick because we're still having struggles. If you have something like this, the first thing you want to do is pull out the elements that are not hydrogen or oxygen. Leave them to last. So underneath here you would put nitrogen, magnesium, then hydrogen and oxygen. Okay? Then you go side to side. 1 nitrogen. This 2 comes through, so you have 2 nitrogens. So I've got to come over here and change this to 2, so now I have 2 nitrogens. Then I go to the magnesium. I've got 1 on this side and 1 on this side. That was easy. Then I go to the hydrogens. Be careful, they're in 2 different places. So I've got 2 here with the nitric acid and 2 with the magnesium hydroxide. That gives me 4. Over here I have just 2. So I'm going to have to times this by 2 to get 4 total hydrogens on that side. Then I go to my oxygen. I'm praying that it worked out. So here I have, with the nitric acid, I've got 2 times 3, which is 6, plus the magnesium hydroxide has 2 times 1, which is 2. That adds to 8. Over here on this side, product side, we've got 2 times 1, which is 2. And the magnesium nitrate has 2 times 3, which is 6, giving me a total of 8, and I'm done. All right? Does that make sense? Those of you that were having struggles, did it help you? Okay, so the next part is way back to where we're starting to work with moles. We need to find the formula mass of each of these. I'm just going to show you really quickly. So for nitric acid, I would write that down and I would go hydrogen is 1.00, is it 7 or 8? I can't, 8. Okay, and nitrogen is 14.007, and oxygen, I have 3 of them at 15.999, and I add that up. I'm going to do that, for magnesium hydroxide, for water, and for magnesium nitrate. Okay, so I'm doing that in that section. In this section right here, A and B, what you're going to do is you're going to take this, whatever this added up, and you're going to times it by the coefficient. So I'm going to go whatever this was times by 2. So I'm going to 2 times this, plus I'm going to add this to it, and that answer goes here. And then on this other side, because these are my products on this side, I'm going to add up water. I'm going to 2 times whatever water is because it had a 2 in front of it. I'm going to add it to whatever magnesium was, and that answer is going to go there. Okay? Does that make sense? Okay, the rest you should be able to do on your own, but I'll be wandering around. I'm going to come get your quiz scores and see what they're doing, and then I'll put up again what you should have accomplished by the end of the day with the end of the day slide. Okay? All right, time is yours.